Welcome Math 200 students to Chapter 4, Section 4.1. Chapter 4, we're getting into probability distributions, all right, which is getting more and closer to how this is applied to statistics. All right, 4.1, so Chapter 4 in general deals with discrete probability distributions as opposed to continuous probability distributions, and we'll find out what the difference between those are. All right, random variables. The outcome of a probability experiment is often a count or a measure. When this occurs, the outcome is called a random variable. So the random variable can take on any value associated with that outcome. So let's read that definition. A random variable x represents a numerical value associated with each outcome of a probability experiment. The word random indicates that x is determined by chance. There are two types of random variables, discrete and continuous. A random variable is discrete when it has a finite or countable number of possible outcomes that can be listed. Finite or countable. In other words, it can be infinite as long as it can be countable or listed in a particular way. A random variable is continuous when it has an uncountable number of possible outcomes represented by an interval on a number line. There may be another way to think about this, which is the way I usually think about it. It's discrete when you skip numbers in your counting. If you go 1, 2, 3, 4, 5, if you're doing that, you're skipping every number between 1 and 2. You're skipping 1.1, 1.2, 1.3, right? So that's discrete. If you go 1, 1.5, 2, 2.5, 3, 3.5, that is also discrete because you're still skipping numbers. You're skipping the numbers between 1 and 1.5, between 1.5 and 2, and so on. Even if you go 1, 1.1, 1.2, 1.3, 1.4, it's still discrete because you're still skipping numbers. There are numbers between 1 and 1.1. It's continuous when you don't skip any number at all, including the irrational numbers between things. So if you say it can be anything between 0 and 1, or 1 and 2, or 0 and 100, anything between those, then we're talking continuous. All right. We'll get more into examples like that. You conduct a study of the number of calls a telemarketer makes in a day. The possible values of the random variable are 0, 1, 2, 3, 4, and so on. Because the set of possible outcomes, 0, 1, 2, 3, can be listed, x is a discrete random variable. I would say because you're skipping numbers, when you say 0, 1, 2, 3, you're skipping numbers between them, then it's discrete. You can represent its values as points on a number line. Okay, so 0, 1, 2, 3, but you're skipping everything between those points. A different way to conduct the study would be to measure the time in hours a telemarketer spends making calls in one day. Because the time spent making calls can be any number from 0 to 24, including fractions and decimals and irrational numbers and so on and on, x is a continuous random variable. You can represent its values with an interval on a number line. So it can be anything from 0 to 24. Now, the number of calls would just be 0, 1, 2, 3, 4, and so on. But the number of hours spent can be anything between 0 and 24. Not just the whole counting numbers. So we could spend, 6.51326665100019 hours on the phone. And so it can be anything between 0 and 24, which makes it continuous. When a random variable is discrete, you can list the possible values the variable can assume. However, it is impossible to list all values for a continuous random variable. Okay. I'll do some of their examples, and I may give some of my own examples. Determine whether the random variable is discrete or continuous. Explain your reasoning. Let X represent the number of Fortune 500 companies that lost money in the previous year. Okay, that can be anything from 0 to 500. That can be 0, 1, 2, 3, all the way to 500. It can't be anything from 0 to 500, right? It can't be, it would never be like 20.316 companies lost money. it would either be 20 or 21. Okay. Number 2, let X represent, so that's discrete. Number 1 is discrete. Let X represent the volume of gasoline in a 21-gallon tank. In this case, it's continuous because it can be anything from 0 to 21 and any number in between them, right? A gallon, 2 gallons, 3 gallons, but it can be also 1.5 gallons or 1.1736 gallons. So it's continuous. All right, let me give you some examples as well. How about the number of stars in the sky? That's discrete. The reason it's discrete is because it's either 2,025,000,000 or 2,026,000,000. It couldn't be 2,025,13767 stars, right? The mass of all the stars in the sky. That would be continuous because it could be any number. It doesn't just have to be whole numbers or anything like that. It could be anything from 0 to a number I can't count as high. What about the number of blades of grass on the earth, or the number of grains of sand on the earth, or the number of atoms, or the number of electrons on the earth? All that would be discrete. Okay, because it's either 1,000,000,005 or 1,000,006,000,000. I know it's more than that, but you get my point. What about the number? How about? Let me think about. How about the length of a blade of grass? That's continuous because it could be anything from 0 to whatever, 0 to 7 inches or whatever. What about the number of teeth in your head? Discrete. What about the length of the tooth? Continuous. What about the number of seconds you've been alive? Continuous. What about when you give your age, though? When you give your age to someone, that's discrete because you're going to say I'm 20 or I'm 21. You're not going to say I'm 20.11175 years old. What about the length of your foot? That's continuous. What about your shoe size? That's discrete because the length of your foot is continuous. It could be anything from 0 to whatever, but the shoe size is either like a 10 or 10.5 or an 11. So it skips numbers. Your shoe size does. Let's see. What about the amount of money you have in the bank or in your wallet or whatever? That is discrete because it skips numbers. Let's say you have $526.43. Well, next you're going to have to skip a number to get to the next number, right? It's either going to be in 43 cents or 41 cents, but you can't have like 42.176 cents. So it skips numbers. Okay, I hope that gives you a feel for it. It's important to distinguish between discrete and continuous random variables because different statistical techniques are used to analyze each. We're going to focus now on discrete, and in Chapter 6 we'll start focusing on continuous. So the rest of Chapter 4 is discrete probability distributions. A discrete probability distribution lists each possible value that a random variable can assume together with its probability. A discrete probability distribution must satisfy these conditions. The probability of each value of the discrete random variable is between 0 and 1 inclusive. The sum of all the probabilities is 1. So the probability of each separate discrete event is somewhere between 0 and 1. The probability of all those different outcomes or events has to equal 1. Because probabilities represent relative frequencies, a discrete probability distribution can be graphed with a relative frequency histogram. All right, you can construct a discrete probability distribution by making a frequency distribution for the possible outcomes, find the sum of the frequencies, find the probability of each possible outcome by dividing the frequency of that outcome by the total sum of the frequencies, and then check that all the probabilities are between 0 and 1 and that the sum of all of them equals 1. An industrial psychologist administers a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown at the left. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. So here are the scores, 1 to 5, and here are the frequencies of those scores. So then you would construct this frequency histogram, a score of 1. You would arrive at that probability by saying that's 24 divided by the total of all those, which is 150. So 24 divided by 150 would give you that 0.16, which is graphed in this bar. 2, first score of 2 would be 33 divided by 150, which would be 0.22, which is that bar, and so on and so forth. And that is the probability distribution for that example. So it's kind of the same thing as a frequency histogram. Verify that the distribution at the left is a probability distribution. So what you have to satisfy the two conditions. 1, are all of these probabilities between 0 and 1? Yes, they are. Second, do the sum of these things, do all of them added together equal 1? And they do. So it is a probability distribution. Again, determine whether the distribution is a probability distribution. Explain your reasoning. All right, number 1. All of those probabilities are between 0 and 1. But they all add up to a number greater than 1, so it is not a probability distribution. Number 2. This one right here, this probability is -1. That's not between 0 and 1, so it's already not a probability distribution. Mean, variance, and standard deviation. You can measure the center of a probability distribution with its mean and measure the variability with its variance and standard deviation. The mean of a discrete random variable is defined as follows. The mean of a discrete random variable is the sum of a particular outcome times the probability of that outcome, and you're adding all that together, which is kind of like the expected value. It's a lot like doing that. So each value of x is multiplied by its corresponding probability, and the products are all added together to get the mean. The mean of a random variable represents the theoretical average of a probability experiment, as it is sometimes not even a possible outcome. If the experiment were performed many thousands of times, then the mean of all the outcomes would be close to the mean of the random variable. Find the mean of this thing, this probability distribution. Probability distribution for the personality inventory test for passive-aggressive traits discussed in example 2 is shown on the left. Find the mean score. So what we do is the score of 1 has a probability of 0.16, so 1 times 0.16 gives me that. 2 times 0.22 gives me that. 3 times 0.28 gives me that. So I do all that, all the way to 5. Then I add all those together, and I get the mean to be 2.9. So the mean personality trait score is 2.9 for that particular example. Now 2.9 is actually not a possible score, but it still can be the mean of the probability distribution. All right, variance. The variance of a discrete random variable is that right there. Standard deviation is just the square root of the variance. All right, the probability distribution for the personality inventory test for passive-aggressive traits discussed in example 2 is shown on the left. Find the variance and standard deviation of the probability distribution. All right, you could go through that process by hand, and it's fine to do that. I think what I would do is I would use a calculator. All right, I'm going to show you how to do this in your calculator. You're going to go to Stat, go to Edit, and in L1 you're going to do all the scores. 1, 2, 3, 4, 5. And in L2 you're going to do the probabilities of those scores, or frequency distribution of those scores. So let's see if I can see those scores here. Okay, there we go. So no, 0.16, 0.22, 0.28, 0.2, 0.14. Okay. Now I go to Stat, click over to Calc, and click option 1 variable stats. For the frequency list, do L1. For the list, do L1. For the frequency list, I'm going to do L2. And the way that I can get L2 up there is, you see this number 2 with the blue L2 above it? I hit second L2. Normally when we just put in these things, we usually, in the past, we just put in a bunch of raw data and we just have an L1. We don't even have an L2, so we just leave that blank. But in this case, we have an L1 and an L2. I click calculate, and now I know my mean. I know my standard deviation. And if I wanted to know the variance, see, it gives me my standard deviation. Sigma is 1.27. That's the standard deviation. If I needed to know the variance, I'd have to take that standard deviation and square it to get the variance. Okay. Expected value. The mean of a random variable represents what you would expect to happen over thousands of trials. It is also called the expected value. The expected value of a discrete random variable is equal to the mean of the random variable. I think that's what I told you earlier. Although probabilities can never be negative, the expected value of a random variable can be negative. Example 7. At a raffle, 1,500 tickets are sold each for prizes of 500, 250, 150, and 75. You buy a ticket. What is the expected value of your gain? All right, I'd like to do this with a pen here. All right. So, what are the different outcomes? I could win. What are you doing? I could win 500, win 250, win 150, or win 75. Or I could lose. In which case, so if I win 500, my actual gain is $4.98 because I had to spend $2 on the raffle ticket. So I actually walk away. If I do win, I will only walk away with $498 more than I had. The actual gain from 250 would be $248. The actual gain from 150 is $148. The actual gain from 75 would be $73. The other option is I could lose $2. I could just lose, in which case I walk away with $2 less, or negative $2, than I had when I started. There's 1,500 tickets, so here's how I get the expected value. I say one outcome is I get $4.98. The probability of that outcome is 1 out of 1,500. Another outcome is I win $250. The probability of that outcome is 1 out of 1,500. Another possibility is I win $150. The probability of that is 1 out of 1,500. Oh, I shouldn't have said that, right? I meant to say, I didn't mean to say $250 or $150. What did I mean to say? I meant to say $248. And I meant to say $148. And the probability of that 148 is again 1 out of 1,500. Or I could win 73. Again, 1 out of 1,500. Or I could lose 2. What's the probability of losing 2? That's the probability of not winning anything. Only 4 tickets are going to win. So that's 1,496 out of 1,500. So what is the expected value of playing this game? You just got to add all this up. If you add all that up, you get negative 1.35. So the expected value of playing that game is negative $1.35. That means however many times you play that game, over the long term, you're going to lose $1.35 for however many tickets you buy. Okay? You should never play something that has a negative expected value. In fact, you should make all your decisions in life based on expected value. I have this outcome, I have this probability of this outcome, I have this other outcome, plus this probability of this other outcome, and so on and so forth. And your decisions should be based on the best expected value. The best expected value. Should you play the lottery? Almost always no, because the expected value is almost always going to be negative. The only time that's not true is when it goes on for so long with nobody winning that it gets to be a higher and higher and higher total. And when the total makes it to where it outweighs the odds of losing, then you should play. But even then, it's kind of weird because you might have to split that total with somebody else if more than one person wins, and then it's still going to be a negative expected value. So you should almost never play the lottery. What else? You could I can guarantee you a way to make money. Make a game like this. It's got a spinner, okay? You could win $1, you could win $2, you could win $3, or you could lose 10. So what you do is you take somebody's $10 bill. You say to play this game, you hand me your $10, and whatever if you spin the wheel, if you land on any of these three, then I give you your $10 back plus $1, $2, or $3, and the only way you lose is if you land on this, and I get you to keep your $10. A lot of people will play that because they'll say, well, I got a better chance of winning than I do of losing. But let's figure out the expected value of that game. They might win $1. There's a 1 out of 4 chance. They might win $2. There's a 1 out of 4 chance. They might win $3. There's a 1 out of 4 chance. Or they might lose $10. That's a 1 out of 4 chance. Find the expected value of playing this game. Let me add all that up. So that's 1/4 plus 2/4 plus 3/4 minus 10/4. 1, 2, 3, 4, 5, 6. 6 minus 10 is -4/4. -4/4. In other words, -1. So the expected value of playing that game is -$1. Which means you, as the owner of this game, are going to make an average of $1 for as many people as play it. So some people are going to win. Some people are going to lose. More people are going to win than lose, but overall, the people that lose, you're going to get more of their money than you have to give out. So anyway, that might be a good money-making scheme for somebody out there. Of course, it might not be too ethical. Depends on how you look at things. I really enjoy expected value. I think it's an extremely valuable concept to think about and learn because it really applies to all decisions in life. That's the last of this section 4.1. I enjoy probability in general and statistics. I hope you got something out of this section. Good luck on the assignment. I'll see you again in 4.2.